We also need to consider whether two events are mutually exclusive. And two events, A and B, are mutually exclusive if they cannot occur at the same time. So if two events, A and B, are mutually exclusive, then the probability of A and B has to be equal to 0. The two values cannot occur at the same time, so there's no way for them to both occur. A and B cannot coexist. In example 8, we want to find the probability of drawing a card from a fair deck that is both a number and a face card. These two events are mutually exclusive. There is no card that is a number card and a face card. So that probability would be 0. No card can be both of those things at the same time. In example 9, we want to find the probability of drawing a card from a fair deck that is a red ace. So we want the probability that a card is red and an ace. This is possible. These events are not mutually exclusive because there are two red cards that are aces out of 52 possible choices, meaning we can calculate a probability of 0.0385. In example 10, we want to find the probability of rolling a fair die and getting an even number less than 2. Keep in mind, if we roll a fair die, we've got 1, 2, 3, 4, 5, and 6 as our sample space. So the probability of getting an even number and something strictly less than 2, in this case, would be 0, because the only value that we have that's less than 2 is 1, which is an odd number. So there is no way to have an even number that's less than 2. We have mutually exclusive events, and that probability is 0. In example 11, we want to find the probability of rolling a fair die and getting an even number less than 4. In this case, that is a possibility because 1, 2, and 3 would all meet that condition. So the probability of even and less than 4 would equal one value. So 2 meets both of those conditions out of the 6 different possibilities, gives us a probability of 0.1667.